You are in the meeting now.
Recording in progress.
All right, good morning. Welcome to Monday, October 4th. All right. So hope everybody had a good weekend. Um, this week, we have a pretty full week as far as material goes. Um, Today we're going to be talking about assignment 10, and then Wednesday we have assignment 11, and then on Friday we'll have assignment 12. Um, kind of giving you a heads up of what's happening. Next week we'll spend 2 days on assignment 13. Um, we have a fall break next week, so no class next Friday, and then the weeks starting the 18th. Um, we review and then have exam 2 on part 1 and part 2 on that Wednesday and Friday of week 8. So, um, already getting into, it feels like we just did exam 1, but we're getting into exam 2 really quickly. So, today is all about addressing your questions over distance, midpoints, and circles, assignment 10. If there's any, again, as always, if there's any lingering work, I'd be more than happy to address questions over those, but my emphasis is talking about, or is to help you with assignment 10. Um, so, as far as announcements go, that's all I really have to say. So, how can I help you with assignment 10?
What's going on October?
Could you say that one more time, please?
What is happening October 13th.
On, alright, on folder 13, assignment 13, is that what you asked?
October 13th. It's
I,
blank.
one, one more time, please, really pronounce, pronounce it.
What is going on October 13th?
Oh, October 13th?
Yes.
Okay, we're just gonna be spending, 2 days, I reserved 2 days to talk about quadratic functions. So, assignment 13 starts next Monday, and I just reserved 2 days to talk about it, in case we need those 2 days. Does that answer your question? Thumbs up, thumbs down? Okay.
Yes, it does.
Yeah. Yeah, sometimes when you I when you speak into those microphones, if you're not really if you speak too fast or if you're not clear, it just gets jarbled up, and I have a tough time understanding. I apologize about that. I apologize about that, but it's just technology. Anyways, okay. What else?
Can you do number 4?
Sure. Alright, so we want to find the distance between these 2 points. And anytime that we're talking about distance between 2 points, we have our distance formula, which is square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared, which is really just is derived from the Pythagorean theorem dealing with right triangles. So I like to just take a moment to label my points. So D is going to be equal to the square root of, alright, here we go, x2 minus x1. So we have negative root 3 minus 2 root 3 quantity squared plus 5 root 6 minus root 6 quantity squared. And what might help us here is to recognize that, number one, we're dealing within each of our parentheses, we're dealing with like terms because they had the same root. These 2 terms have the root 3 in them. These 2 terms have the root 6. And it might just help to put a coefficient in front of these roots. So now I have negative 1 root 3 minus 2 root 3. Well, just combine your coefficients together, so negative 1 minus 2 is going to be a negative 3 root 3 quantity squared. Plus 5 root 6 minus 1 root 6, that's the same thing as 5 minus 1, so that's going to be 4 root 6 quantity squared. Alright, so before I go on, just a little thought. If you have a times b to the second power, this is equivalent to a to the second, b to the second. The exponent of 2 gets applied to every single factor inside our parentheses. Everything's still under square root, so we now have negative 3 to the second power times root 3 to the second power plus 4 to the second power times a root 6 to the second power. Then we can start evaluating. Negative 3 squared is going to be 9. Root 3 squared is going to be 3. 4 squared is going to be 16. Root 6 squared is going to be 6. So this gives us the root of 9 times 3 is 27. 16 times 6, that's going to be 96. Which then we can add those two together. That's going to be a 123. And then I would ask myself, always ask yourself if you can simplify. And so, since 123 is odd, no perfect square that's even is going to divide into it. So things like 4 or 16 or 36, none of those divide nicely into this. 9 is a perfect square. Does 123 divide by 9? No. Let's see. 12 divided by 9 is going to be 1 with the remainder of 3. 33, nope. 25 is not going to work. 49 is not going to do it. So, no, we can't simplify this any further, so we are done. So, for this particular problem, I mean, this is a number one, you have to know your distance formula. Have to know this guy. You have to know them and they have to know how to utilize them. And this is a nice little problem because it's making us think about like terms and how do we deal with combining radicals together. All right, to the person that asked this question, does this make sense? Yes? No? Maybe so?
Yes, thank you.
You're very welcome. Okay?
Can you do number 12?
Did you say that was 12?
Yes.
We have 2x squared plus a 2y squared minus 12x plus 24, try to write that better, 24y minus 72 is equal to 0. And basically, we want to take this equation and we want the equation of the circle in our standard form of x plus, or x minus h quantity squared plus y minus k quantity squared is equal to r squared. That's the goal to get there. We want the equation of the circle because once we have it in this form, we can do lots of things with it. Mainly, we can graph. If I have an equation of circle in this format, I can graph that circle because if it's in this format, I can tell you what the center is and I can tell you what the radius is just by looking at the equation. So in order to get into this form, we got to take this equation and we got to go through that process of completing the square. And in the process of completing the square, something that we always need to make sure that we have is we must have a coefficient of 1 for our x squared and our y squared. So I'm looking, excuse me, I'm looking up here and I notice that these both have a coefficient of 2, 2x squared plus 2y squared. So in order to get this must have, you must have a coefficient of 1. What we need to do is we need to go through and we need to take this equation and we need to divide by 2. So if I go through and divide by 2, I get x squared plus a y squared minus 6x plus 12y minus 36 is equal to 0. Alright, so that's the first thing that we want to do. We want to divide by 2 in order to get that coefficient of 1. And now we can go ahead and proceed with this. First thing I'm going to do is I'm going to start grouping my x's and y's together, and I'm going to get this constant to the other side. So I have x squared minus 6x. I'm going to give myself a little bit of space, plus the y squared plus 12y, and this is equal to positive 36. Now what we want to do is we want to go through and add this thing called b over 2 quantity squared. Maybe I should indicate, alright, that this is the b over 2 quantity squared for my x's, and this would be the b over 2 quantity squared for my y's. Alright, so b is the negative 6, so negative 6 over 2 is a negative 3, squared is 9. B is 12, so 12 over 2 is 6, squared is 36. Okay? Now, what we get to do is we get to factor these two trinomials. This is going to become x minus 3 quantity squared plus a y plus 6 quantity squared is equal to Alright, 36 plus 36 is 72, plus the 9 is going to be an 81. Which, if I take it one step further, I could write this as 81 is equivalent to 9 squared. And now we have it in this format where I can start to identify the, this is the format that you want. This is the equation of the circle. I just did this down here. We'll put that in parentheses just so that we can see what R is. But now it's in our standard form for the equation of the circle. So from here I can just start doing several things. I can start to say that the center is at, so the easiest way to do this is just to think about what's the opposite of 3. That's going to be positive 3. What's the opposite of 6? Negative 6. My radius, what squared makes 81? That's going to be 9. And I know it didn't, apparently it didn't ask for this, but the nice thing about this information right here is I could go through and graph the circle. I'm not going to try to do this exactly because I have a really large radius, but if this is 3 and this is negative 6, I would go up 9, so that I would go all the way up to 3. I'd go across 9 all the way to 12. I would go down 9 all the way to negative 15. You can see it's not going to be exact, nice, great looking circle all the way back here to negative 6. And I could graph this circle. Alright, so that's an ugly looking graph because it's not exact, but that's what you get to do once you have the equation in the standard form of a circle. You can determine the center and the radius, and we're done. Again, to the person that asked about this, the process, how we derived our answer. Does that make sense?
Yes.
So, for problems like this, you have to know, what do you have to know here? You have to know this process. How to go through and complete the square. You have to know that process for equations like this up here, and go into that process of completing square, and interpret this equation correctly.
Can you do number 7?
7. We want to find the midpoint between, so very similar to, I guess it's problem 4 that we did. Very similar in that we're dealing with endpoints that have these radicals, have these square root values attached to them. Alright, so the midpoint You have the midpoint formula. Again, this is something that you have to know. x1 plus x2 over 2, comma, y1 plus y2 over 2. There is our midpoint formula. So we're taking the sum of the x's, dividing it by 2. We're taking the sum of the y's, dividing that by 2. And this is a xy coordinate that gives us the midpoint. So again, I call this my my insurance policy. I'm labeling my points so that I don't mess things up in the plugging in process. So here we go. We have x1, so that's root 6, plus x2, so that's going to be 3 root 6 over 2. And then y1, so that's going to be negative 2 root 2 plus y2, it's 10 root 2 over 2. And if it helps, recognize that there's a coefficient of 1 in front of that root 6. So now it's just a matter of combining our like terms together. 1 root 6 plus 3 root 6 is going to be 4 root 6 over 2. And then negative 2 root 2 plus 10 root 2. Again, the only reason I can combine these together is because they have the same root 2. If this was root 2 and a root 5, I could not combine these two together. We'd have to do some more advanced mathematics to see if we could combine those together. But we're not going to encounter that problem in this class. We're going to be able to combine these two values together. So that's going to be 8 root 10 over 2. And now I want to simplify. So if it helps, you can think of this as 4 over 2 times the root 6.
And the square root, isn't it a 2?
I'm sorry, what? Oh,
Inside
yeah.
that square root, should it be a 2?
Yeah, so, yeah. Root 2. Yes, you're correct. Root 2. And then you could do that. And now I can think about simplifying these two guys. So 4 over 2 is 2 times root 6. 8 over 2 is 4 times the root 2. And we're done. Root 6, root 2 do not simplify. So again, what do you have to know here? You have to know your midpoint formula. You have to know that guy. You have to know how to implement him, how to use the midpoint formula. And again, we also just have to be okay with this combining terms together that have these square roots attached to them. And because they are like terms here and here, it's just like adding 1x and a 3x together. We know that 1x plus 3x is a 4x. Well, I'm just replacing that x with this root 6. So this is like saying, what is negative 2x plus 10x? Well, that's going to be 8x. We'll just replace that x with this root 2. So I don't know if you've caught on, but instead of saying square root, we can just say root 2. That's just the shorthand way of saying square root. I can just say root 2. All right. Hope that helps. Does that make sense to the gentleman that asked about this question?
Yes, sir. Thank you.
You're welcome. What else can we look at?
Can you help me on domain and
What number was that?
10?
So, to start off with number 10, how about we go to something that we already looked at? Going back to 12. So going back to 12, and since I've already written this down, and hopefully you did too, let's go back to this standard form of the equation of a circle. So, when we have the standard form of the equation of a circle, the center is HK. Now, it's important to see that you have x minus h quantity squared, y minus k quantity squared. These minus signs are in there for, as part of the standard form, so it's not minus h minus k, it's the h and the k. So if you look back down here, what we did with number 12, if I'd say x minus h quantity squared plus a y minus k quantity squared, you have x minus h, you have x minus 3. H is the x coordinate of the center, so 3 is the x coordinate of the center. It's not negative 3, it's 3. Now, look at this. It's y plus 6. Well, that doesn't match our form of y minus k. So how do we get y plus 6 to look like y minus k? Well, we could rewrite this as y minus a negative 6. Isn't that the same? Y plus 6 is the same thing as y minus a negative 6. What do those two negative signs do? They come together to make a plus sign. So now you have the y minus k. Well, in this case, k is a negative 6. So that's why the center back here is at negative 6. And then the radius is the r. Now, in the form of the equation, it's always equal to the radius squared. So that's why when I looked at 81, I had to ask myself, 81 is equal to r squared. Well, what is r? What squared makes the 81? Well, it's the 9. 9 squared makes 1. That's why the radius is 9. Alright, so first of all, are we okay with, let's just go back to your question you asked about problem number 10. We have an x plus 3 plus a y minus 2 squared is equal to 81. So what I want to do is I want to compare this to our standard form of x minus h quantity squared plus a y minus k quantity squared equals r squared. So you can see that I have not x, but it's an x plus 3. It's not x minus h. So what if I just think about this as rewriting x plus 3 as x minus a negative 3? Then I can see that when it comes to my center, that the x coordinate is going to be negative 3. And compare this again, y minus 2 quantity squared to y minus k quantity squared. Y minus 2 is the k. So there's my center. And so what I said about number 12 was, I said another way to think about this is just, what's the opposite of negative 3? It's positive 3. What's the opposite of positive 6? That's negative 6. That makes your center. So going back to number 10, what's the opposite of 3? It's negative 3. What's the opposite of negative 2? It's positive 2. There's your center, and no surprise here because we just looked at it, but the radius, let's learn how to spell radius, R-A-D-I-U-S, is equal to 9, because 9 squared is equal to 81. Does that answer your question about problem number 10?
No, I was asking for domain and range.
I'm sorry, what?
I was asking for domain and range.
Oh, the domain and range? Does it ask that
Yes.
question?
Yes.
Oh, I didn't hear you ask about domain and range. Oh, there's other parts to this. I didn't see those other parts. Okay. So what does it tell us to do next? It tells us to graph. So I'll try to make this a better graph. So so here we have negative 3, 2. So I'm just going to go in these 4 directions, your compass, 9 in each direction, because I could tell I already ran out of room. So if you're at negative 3 to go 9, you're going to be all the way out here at 6. So I'm just going to put 6 right there. If you're at 2 and you go down 9, you're going to go all the way down here to a negative 7. If you're at negative 3 and you go 9 this direction, you're going to go all the way here to negative 12. So that's going to be this point right here. And then if you're at 2 and you go up 9, you're going to go all the way up here to 11. Alright. I was being a little bit lazy here because I didn't plan for this properly. But you need to plan for this a little bit better when you go through and graph. And when we talk about the domain and the range, the domain is the set of x values that are on this graph. Domain. What x values are represented on this graph? Well, when we went 9 to the right and 9 to the left from this point right here, that established our domain. So 9 to the left took us to negative 12, 9 to the right took us to 6, so our domain is from negative 12 to 6. Does that make sense?
Yes, thank you.
So, you tell me, what is our range?
-7, -11.
Negative 7, yeah, that's positive 11, yeah. Negative 7 to positive 11. Okay. Sorry, I didn't catch that you just wanted to do domain and random. Spent way too much time going back to number 12. Anyways, moving on. What else can we look at? Anything?
Can we go over number 3?
Yes. So again, the distance formula. X2 minus x1 quantity squared plus y2 minus y1 quantity squared. I like to label my points. I encourage you to do the same thing. Now, you might be looking at this and you might be saying, oh my gosh, got fractions here. But you know what the nice thing is about these fractions is that the way that we have these ordered is that you don't have to do any manipulation of the fractions in order to combine them together. Because you'll notice that the x's have the same denominator and the y's have the same denominator. I mean, if I really wanted to get you thinking about this problem, I would introduce fractions that don't have the same denominator. I'd give you something like 1/4 minus 3/5. Then you have to go through and do some extra work. But fortunately, the way this was constructed, we don't have to do that extra work. All we have to do now is combine our fractions together. So negative 1/4 minus 3/4, we're just going to take the negative 1 minus 3, that's going to give us a negative 4/4 quantity squared, plus negative 1 minus 6, that's going to be a negative 7/7 quantity squared. I would simplify the fractions before I square them, so you get negative 1 quantity squared plus a negative 1 quantity squared, which then that becomes 1 plus 1 square root of 2. Now, was that so bad? So, I would see what happens if you did something like, try doing something like this. What if you had the points 3/4, 6/7, and let's change it up a little bit to, I don't know, 1/4 to, I don't know, 5/7. I don't know. I don't know where that, we're not going to do it, but you know, just try to see if you can make that happen. Try to see if you can figure that one out. All right, what else can we look at?
Number 16.
We want the equation of a circle. So I'm going to stop right there. Whenever I say the equation of the circle, I want it in standard form: x minus h quantity squared plus a y minus k quantity squared equals r squared. We want it in that form. So what is the equation of the circle? Where we are given that the center, we're looking at 15, is at the origin, and it has the point for -2. Alright, well, if the center is at the origin, we know that that point is 0, 0. So we know that at this point we could plug in 0 for the h and 0 for the k. That gives us our h and k. But we still need to know what r is. Now just take a moment to picture this. Here's the origin, and we're dealing with a circle, right? So we know that this is going to be a circle around the origin, because we know it's a circle, and it says that it contains the point 4, -2. Now, 4, -2, I'm just going to pretend that that's the point right there, 4, -2. 4, we'll call that -2 right there. That's the point 4, -2. Now, we're looking for the radius, right? That's the missing bit of the circle. Well, the radius is that line segment, right? This is the radius. Man, I wish I knew what that length was. Well, what if I make a triangle where the height of that triangle is the -2, because that's the, or we'll call it, we'll just call it -2. Or rather, we'll just call it 2. We don't have to deal with negatives. Where the height of the triangle is the distance from the origin down to the y value, and the length of the triangle is the distance from the origin to the x-coordinate. Now, to find r, we can use the Pythagorean theorem. We know that r squared is equal to 2 squared plus 4 squared. This is the Pythagorean theorem, which means that r is equal to the square root of 4 plus 16, which means r is equal to the square root of 20. That's our radius. This length from here to here is the square root of 20. So we get to now plug in 20 for our r. So let's fill everything in now. We have x minus 0 quantity squared plus y minus 0 quantity squared is equal to the square root of 20 quantity squared. And then I would consider simplifying this. Because we're subtracting 0, x minus 0 is just the same thing as x squared. Now, if this was something other than 0, I would leave it as x minus whatever quantity squared, but because we're just subtracting 0, we just say x squared. Same thing for y squared is equal to the square root of 20 squared. We want to simplify this. Well, the square root and the exponent
Your
of 2 cancel
conference is
each other.
scheduled to end in 2 minutes.
The square root of 2 and the exponent of 2 cancel each other out, and that just leaves us with 20. So, yeah, that's how you do problem number 15. Problem number 16 requires a little bit more work, and I don't have time to go through 16. But 16, the idea is you have a circle, and we have these endpoints here and here. So you got to use these endpoints to, one, find the center. Guess what you're going to use? You're going to use the midpoint formula. And then you got to find the distance and then you're going to take that distance and divide it by 2 to give you the radius. So you have to use the distance formula here. Alright, well that's all the time that we have for today. We start Wednesday talking about
Your conference is now over. Goodbye.
combinations and composition of functions. Shoot me an email if you have any questions. Have a good day.